In this question, we're again using the Lewis structure of a molecule to figure out its shape. This time we have some more advanced molecules, including those with reduced or expanded octets. So in this question, we have SCl4. We can see our Lewis structure drawn there. The first question is, how many electron domains do we have? Remember, any bond, single, double, or triple, and any lone pair counts as an electron domain. So we've got 1, 2, 3, 4, 5 electron domains around our central atom in this question. Now we can use our reference sheet to figure out the geometry. So we're looking at the number of electron domains in that first column, and we want 5 electron domains. And looking across to our next column for the geometry, the name of this is trigonal bipyramidal. So the geometry of this molecule is named trigonal bipyramidal. Okay, next we need to look at the number of lone pairs. So looking at our Lewis structure here, we have just one lone pair. And we need to figure out the shape of this molecule. So going back to our reference sheet, we're looking along the top row to find the shape with one lone pair. Here it is. And looking down to our row where we have 5 electron domains, that's going to be the seesaw shape, which has bond angles of just less than 120 degrees and just less than 90 degrees. And to help you visualize that, if you look at the trigonal bipyramidal shape, and then we remove one of the atoms and replace it with a lone pair, you'll see that's where the seesaw shape comes from. And again, those angles are slightly less than they would be in the trigonal bipyramidal molecule because that lone pair of electrons has extra repulsion and it pushes those other atoms around just a little bit so the angles between them get squashed. So the shape of the molecule is seesaw, and the bond angles are slightly less than 90 degrees and 120 degrees. Lastly, which image best represents this molecule? Well, looking at our options here, D is the seesaw shape. So our image is going to be image D. So as you can see, these questions work exactly the same as the simpler ones, but we now have more options down here with 5 or 6 electron domains when we have our expanded octets.